All right, let's talk about a term you hear absolutely everywhere, machine learning. What is it really, and more importantly, how does it actually work? Let's dive in and demystify it.
First off, you gotta know this isn't some sci-fi future tech. Nope, it is already here and it is all around us. For instance, it's what lets a self-driving car look at a busy street and instantly identify other cars, pedestrians, and traffic lights.
It's also doing some pretty amazing things, like breaking down communication barriers. It can look at hand gestures in real time and translate them right into text, making our world a little more accessible for everyone.
And it's the powerhouse that can sift through mountains of traffic and location data to tell a taxi driver exactly where to go to find their next fare. So you see, it's powerful, it's already here, and it kind of makes you wonder, how on earth does a computer learn to do any of this?
So that brings us to the real heart of it all. We've seen what it does. Now, let's pull back the curtain and find out how computers actually learn.
Believe it or not, the core idea goes way, way back to 1959. Arthur Samuel defined it perfectly. And the key phrase, the part you really need to hear, is without being explicitly programmed. This means we're not sitting there writing code for every single possible outcome. Instead, we're building a system that can figure things out on its own.
And this, right here, this is the fundamental shift. With traditional programming, you give the computer data, you give it a very specific program, and it spits out an output. Machine learning completely flips that on its head. You give the computer the data, and you show it the outputs you want, and it writes the program for you. The data itself creates the logic.
Okay, so how does this learning actually kick off? Well, there are a few big ways, but the most common one is called supervised learning. And honestly, the best way to think about it is like you're studying for a test, but you've been given the answer key ahead of time.
The idea is pretty simple, really. You show the machine thousands or even millions of examples where the right answer is already known. You show it a picture and say, that's a cat. You show it another and say, that's a dog. You feed it an email and say, this one is spam. After seeing enough of these labeled examples, it starts to figure out the patterns all by itself.
Now, inside this supervised learning world, you're usually asking the computer to do one of two main jobs. The first is called regression. That's all about predicting a number on a continuous scale. Think the price of a house or the temperature tomorrow. The other job is classification, and that's about sorting things into buckets. Is this email spam or not spam? Is this tumor benign or malignant?
And this illustrates that difference perfectly. You see, on the left, regression is trying to predict a price, a number, that could be anything along that line. But on the right, classification just has to make a choice between two distinct labels. It's either one or the other. So one predicts a number, the other predicts a category. Simple as that.
Okay, but what if you don't have an answer key? What if all you have is a giant, messy pile of data with no labels at all? Well, that's where the second major approach comes in, and it's called unsupervised learning.
With unsupervised learning, you basically just dump a whole lot of data on the computer and say, find something interesting in here. It's kind of like giving a kid a huge box of Legos. You don't tell them to sort by color or shape, but they'll naturally start making little piles of similar pieces. The algorithm has to find that hidden structure all on its own.
A perfect everyday example is Google News. The algorithm scans thousands of articles from all over the web and automatically groups them together if they're about the same story. Nobody went in and labeled them. The machine just saw that a bunch of articles mentioned words like panda and zoo and newborn cub, and it figured out, hey, these are all probably talking about the same thing.
So, we've got these two big ideas, learning with an answer key and learning without one. But to really get it, to see how a machine actually learns, we need to peek under the hood. We're going to walk through a really simple example to see the core engine that makes almost all of this work.
So let's head back to our house price example. Each of those little red X's is a real house. We know its size and we know the price it's sold for. Our mission, should we choose to accept it, is to get the computer to draw a line that can predict the price of a new house just based on its size. Now, here's the puzzle. The computer could draw a basically infinite number of lines through that data. So, how does it know which one is the best one? What does best even mean to a computer?
Here's the secret sauce. The algorithm has a way to measure how wrong it is. It's called a cost function. The easiest way to picture it is like this big 3D bowl. Every possible line the computer could draw corresponds to one spot on the surface of this bowl. A really bad line that's way off, it has a high cost, so it's way up on the rim of the bowl. The absolute best, most perfect line, it has the lowest cost, and it's sitting right at the very bottom. The entire goal of learning is to find the bottom of that bowl.
And the process starts with just that.
a totally random guess. As you can see, this first line on the left is a terrible predictor. And on our mistake bowl on the right, that guess puts us way up high. A very high error, a very high cost.
But then, the learning begins. The algorithm makes a tiny change to the line and checks, did my cost go down? Yes, it did. So it knows it's heading in the right direction. It's heading downhill. You can see the line on the left getting a little better as the dot on the right literally rolls down the side of the bowl.
And it just keeps doing this, again and again and again, maybe thousands, maybe millions of times. A tiny nudge, check the error. Another tiny nudge. It keeps going until it can't go any lower. It has found the bottom of the bowl. At this point, the machine has learned the relationship between a house's size and its price.
So when you strip away all the fancy math and the complicated terms, this is all machine learning really is. It's just a clever, automated process of trying something, measuring how wrong you are, and then trying again, intelligently, to make that mistake as small as you possibly can.
And that incredibly powerful yet beautifully simple idea, that process of rolling downhill to get rid of mistakes, that's the engine that drives everything we talked about. It's what powers your spam filter, and it's what's helping a car learn how to navigate a busy street.
This technology is fundamentally changing our world. It's finding answers and patterns and data that no human ever could. Which really just leaves us with one final big question. Now that we can teach computers how to learn, what's the next great problem we should ask them to solve?